sales engineer from our UK office, and today there's another session on Dockers today, which just happened, which was around configuring Docker images. And this particular session actually deals with persistence in the world of containers. And more importantly, it focuses on the work that we have done as part of Cache or InterSystems IRIS, which makes us work as a first-class citizen in the world of containers. Because when you're working in the world of containers, one of the important things that you want to achieve is a clear separation between the code and the data, which allows you to easily upgrade your applications by swapping your containers. So one of the things which has always been with Cache and InterSystems IRIS is that most of our system configurations, whether that are your security services or their users, roles, privileges, or there are any SSL connections that you might define, or all, in short, the entire MGR directory actually resides within the installed directory of Cache instance, which in turn means that if you are trying to run an instance of Cache or IRIS in a container, that particular storage becomes local to the container. And what happens if I bring an upgraded or a new image of my application and try to do away with my old image, then all the configurations that today I have on my instance of Cache running in my current image gets lost. What do I do about that? Obviously, there is a way in Docker that you could commit and create a new image, but that pretty much defies the whole idea of using containers, where the whole idea of using containers is that whatever you do as part of the build phase and run phase are completely different. So once you have basically come up with the correct definition of your image, which in a sense is your Docker file, then that image actually carries along through the entire provisioning process, what goes from the development to the quality assurance and finally to the production environment, and you don't want anybody to change that particular image. So what work has gone into Cache or InterSystems IRIS data platform to allow you those capabilities? We'll discuss that today. Just for the purpose of introducing containers, what are they? We have all been used to virtual machines now for quite a bit of time. Container, I would say, is the next level of abstraction, and it's pretty much abstracting your entire application or containing your application in a unit of work which is called a Docker image. It basically does not require a complete OS by its own. It only uses OS when it needs to use, unlike VM, which has its own version, its own instance of OS running in each and every VM. And as you can see, because containers themselves are actually only using the OS in a shared mode, so containers could work on a host OS. They could even work on a host OS running on a VM. So unlike a virtual machine, they do not need to have a complete operating system as part of them, and that's the reason they're so lightweight. And when you have a container, the amount of space it takes or amount of time it takes to start an instance of container, it's quite small as compared to the virtual machine. Why use them? I mean, there are multiple benefits. Right away, starting from, I would say, people use containers to say, okay, I have a big development shop. I need to onboard my developers. How do I make sure that whenever somebody joins my team, by running a single command, how can I provide him an access to my development environment rather than spending 3 days in configuring his machine, which probably is close to what we are using currently for our development environment. So if all the things that our application development environment require are packaged in a unit of work, which is a Docker image, then if somebody comes in, I can just give them the Docker image, they can run that image, which becomes a container, and then they're all set and started working on it. Things like testing, which in the previous session we were talking about. If somebody's trying to test an application, how many times do we run into those issues where once we have run the test cycle, oh, now I need to run the scripts again to make sure I can test them again. I need to remove the data. Whereas if you are running with containers, then you have the same base image. You run it in a container, you perform all your series of tests, and once you are done with that test cycle, just do away with that container. You still have the base image which you can again start with. Or if you want to store the state of that testing cycle, because maybe you run across certain bugs and you want to pass it back to your developer and see, can you check why are we experiencing these issues? So there are a host of advantages, and obviously the biggest advantage is that you want to take away the risk which happens today in deploying changes to your production environment. Because what's happening when you're using in the world of containers is you're starting with an artifact which actually comes out of your build process, and that artifact is actually finally getting deployed both as part of your testing and production environments, and nothing is changing over there. So it's a consistency and lack of risk which is actually making people embrace containers faster and faster. Just three main concepts I would say about Docker. So a Docker image in itself is a read-only and acts as a template. It is defined in a Docker file, and so the template itself is a plain text file like a Docker file, and there is a build command, and whatever you have defined in that text file, whatever are your applications, dependencies, everything is all contained in that Docker file, and when you build it, you come up with an image. And that's what, after you have built your image, goes to your provisioning pipeline of testing and back to the production. Container is just a runtime instance of an image. So once you have created your image, you can have multiple containers running on the same image. So it's like a runtime instance. And obviously, the whole idea is that when you're building your image, you start from a starting point. I mean, you could completely start from scratch, but more often you start from something. So like, for example, if you're trying to build an image for your application, then typically you would be starting from the base, from the image that we provide, which would be Cache or InterSystems IRIS already installed on a particular OS. So that you don't have to worry about that. And all you have to worry about is you take that image, add your application dependencies on it, which includes your application code or all the other things that you need as part of your application, build your image, and that becomes your image which you are trying to then run as a container. So these are the three basic concepts, if you ask me, apart from obviously as complex they could be, the more detail you go into. But principally, I think so the most important thing is that there are two main parts to any container-led development is you're isolating the build and the run phase. So there's a complete build process which is basically resulting into your baseline, which is a Docker image which consists your application and all its dependencies, and that's what then you are provisioning as part of your provisioning process. And as I said, it basically supports this whole idea of continuous integration, and as you are coming up with newer and newer changes, then it's basically working at the image level, and it's the image which gets deployed across multiple environments. Okay. So if you were to look at a simple example, how does Docker work with InterSystems Cache or IRIS? So typically you have is what we call as images. So I have an image of InterSystems IRIS, which I downloaded 12 days ago, which is our global summit image. So this is the image that typically InterSystems would be providing to you. Today it's through a private internal repository, but very soon we'll have an official repository where you would be able to pull images of Cache ensemble of InterSystems IRIS from that official public repository. Now, once you have this image, then you can actually run these image in a container, which would actually, so what you would do is typically say Docker run. You will run it in background. You could give it certain ports that you want to expose. Sorry. So there are two ports typically you want to expose. One is your super server port, and the other is the web server port. You could give it a name. So you could give a name to the container. That's Gupta. And finally, you give the name of the image for which you are trying to run this container. Minus detach is just you are running it in background. And if I say this now, I see IRIS. Sorry. So if you look at this command, if you look at, whenever you look at any image, there are two main parts of any image. One is the actual image name, and the other is the tag. And tag in the Docker terminology is almost like versioning. So this is the current version that I'm using, which is the GS207. So imagine if you are working in a software development shop, there would be different images with different versions, and depending what you're pushing to the production, you would be using that particular image. And when you run it at this particular time, now you have this running instance of image, which we call as a container. And if I go over here, you can see that there is a container running. It generates its own internal container ID. It shows and it is using the C container main process that we have developed. These are the two ports exposed. Now, C container main is again an important thing that we have developed as part of Cache and InterSystems RS. The reason is, the way Docker works is that it almost runs something and expects it to give an output and come out, almost like a function. So C container main is our process which we have built as part of InterSystems Cache and RS, which actually provides an entry point. So what it means is that when you say a Docker run command, then it actually starts the C container process as PID1, and it holds that process till the time your database is running, because your database needs to be running. And internally then C container main starts the C control start and all the stuff that we need for starting cache. And similarly, when you stop Docker, then C container main also issues the C stop command so that we can do a graceful shutdown of the database. So now when we have run this instance of cache, I can log into this. Okay. And now I can even, I would say, go interactively into the container. So I've called it sgupta bash. So I can go into my install directory. Okay, and if you do NLS, so you will see all the cache contents of the directory. Now, typically when you have cache, there are a lot many things that you need to do, whether you're creating certain users, roles, privileges, or you're changing certain parameters. So let's say if I change this parameter and make it at 462, save. Now currently what has happened is, when I have changed this parameter configuration has changed in my CPF file, but that CPF file is local to the container. What it means is that if I were to, let's say, stop this container, okay, sorry, because I'm in the shell, so I need to. So if I were to stop this container, then at this particular point, whatever configurations that I did were part of that container. And if I were to, let's say, run another container, let's say with the same command, but this time I call it something new, because I'm still using the same image. And if I were to run a new container using my old image, then I would have lost this change, because the configuration change that I did to cache was local to that container. And remember, container is the runtime instance of an image. It has its own storage, that's why it got stored within the container. But then how do you pass that information back to another container which might be running on the same image? So if I go back now, obviously we came out of this, but we stopped this. And if I go now over here, and if I go to memory and startup, you will see it's still the old value. The reason is because the value which I changed got changed into the cache CPF, which was local to that particular container. So it never got persisted into the image which I had built. Now Docker does provide a way that if you have done some changes on top of the image, you could do a Docker commit command. So potentially what I could do is create a new image by using Docker commit command. But then the whole idea of Docker is, you do not want to change your image as part of your provisioning process. You want the same single artifact to be working as in whatever was created as part of the build process, and you don't want to be doing the changes to that artifact as part of your deployment process. So how do we do this? So that's where the need was felt, and that's where we have developed what we call as the %sys durable, or the persistence in the feature of our cache. What it does is that when you basically run a container, you can specify a volume of your host OS in an environment variable, which allows cache to copy your entire MGR or the cache sys.dat into an external file location, which is on a volume on your OS, not local to the container, and points any pointer, any changes that you will do to that external file location. So what it means is then that any cache configurations are now no longer local to cache or iris. Everything is now, all the cache configurations of whether it's the cache sys.dat or it's all the user roles, privileges, whatever you might have defined, they're all now stored in an external file system. And as long as you keep the same environment variable and the same location, I could take another image and actually run that image against the same location, and all those parameters, all those configurations would be available to you. The idea is that, yeah. I mean, you could do that, but you would want them to have the same location. So you could have 3 containers running and pointing to 3 separate OS locations, but the idea is to make sure that they are pointing to the same location. And the let's say, the use case where it works or where it's most needed is, so if you have an application running on cache or iris today, okay, and it's running on a container and you have that image which is there. Now if you want to upgrade that, and assuming that you have your application data already separated, and you have not done much schema changes and you're just propagating an application code change, then while upgrading, I no longer have to, I would just be swapping my new image, which has the new application code, and pointing it to the external locations of that file system, which holds the cache configurations for the current production instance. And all your roles, privileges, and all would be automatically available to you in that new instance. Yeah. 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 Exactly. So it does maintain its local copy in the install directory as well, but it's pointing it to the external location. The code typically would be part of your image which you are building actually, because that's your artifact. So that itself would in any case be changed, because when you're upgrading, you're more often actually upgrading because some application code is changing, or it's a new version or whatever it is. So that code itself would be typically local to the container, but the data, if you ask me, let's say typically what your application generates would be in a separate file system on your OS host. You won't be persisting that within the container. And similarly, all the cache configurations by using the %sys durable feature would also be in the external file system. Okay. So now, so basically, I can stop this container, and instead of using the normal way of running a Docker container, we'll look at now actually how we can use the %sys durable feature. So the idea of containers is, one of the principal way of working with containers is you are always looking to how do you separate code versus data, because you want your container to be just a placeholder or the storage for your code. And that's how we provide this durable %sys feature, which allows you to use a volume within your OS, which basically gets mounted when you run your Docker container and is accessible within the container as well. And you can actually specify all the different parameters. And all you are doing is basically specifying an environment variable, which we call as IOC Data Directory, which holds that location, and it is actually copying your entire cache sys directory and the sys.dat into that location. These are the things that we are actually copying as part of the %sys feature. So what you are doing is, as part of your run command, you are basically mounting a volume from your external host, which is your host of the machine, and basically providing an environment variable, which is the IOC Data Directory. And then what it does is that when it actually runs that container, then it actually puts all those configurations within that. So I'll just show you what I mean by that. So if I look at this moment, the only place externally on my volume is a license key, which is actually holding the license key. So now when I do something like this, so if you look at it, I'm still passing the same parameters. Just a second. I'll just clear it so that people can see it at the back as well. So when I'm running this, I'm still running in the background. I'm publishing the same. Okay, in this case, I'm just publishing 57772. So I'm mounting a volume on my OS environment directory, and I'm accessing that during that. And within that, I'm creating a folder cconfig, which would actually hold all the configurations of cache that we are trying to run. Oh, sorry, I didn't remove my previous container, which was Gupta. Okay. So now when I have done this, at this particular point, now if I try to, let's say, log in Iris, okay. Sorry. So it typically looks like the same thing, but now you would see is, if I go in my data durable, you will see there's another folder or a directory which is created, which is cconfig. And if you look at this now, all the things that we need as part of cache configurations is now copied to this external OS volume. And once it is this, now my container is now no longer holding the cache configurations. So if I say docker stop sgupta, in fact, before that, let me change this value to a modified value so that we can see the difference. So let's say 4. So I'm changing one of the memory and startup value. So now if I stop this container, okay, sorry. Again, when you do a stop on your container, behind the scenes, C container main does the C stop. That's why it takes a little bit more time, so that it does a graceful shutdown of your database. And now if I look at my containers, I don't have, so I could even now remove my sgupta as the container, because when I changed my value of my memory, that value configuration is now stored in an external file system and is no longer local to that particular container. And that's because of the %sys durable feature of cache. And now if I remove this, and if I were to start this again, and if I go back here, and if I go my at memory and backup, you will see it's the modified value. So in principle, what we have done is now my container no longer, so I can just do away with my containers without worrying about the fact that any configurations that I would have created as part of my install, which are stored in cache sys or any CPF changes, they're all now external to the OS system. And whenever I run a new container based on a new image, it can pick up those configurations from that external file system and would be available to you. So this enhancement within cache and InterSystems IRIS is basically done completely from this idea in this world of containers, where we want to be the first-class citizens of containers, where you can have a clean separation of your code and data, and typically what you would have local to your container persistence would be your application code. So, couple of things. What happens if the percentage durable sys directory does not exist? Then, like any other thing, it would still continue the same way. The only difference would be is that now it's still using the cache sys directory of the local install. And if it exists, then at the time, typically when it happens in the time of upgrade, the external volume is mounted, data is upgraded, and all the instances internal pointers are reset to that directory, and instance uses the data. To make this work, both the IOC Data Directory and volume options need to be specified, because you could just mount a volume without specifying the IOC Data Directory. In that case, the only difference is it will still run the container, but it will run like a normal container where all the configurations are local to that particular container. Important aspect is obviously if you are storing these external configurations outside your container, because when you're running a container, your image holds everything, is your artifact. You have packaged everything, which is already in source control through your Docker repository, through your tagging. But if you are storing these external, these configurations in an external file system, obviously then this needs to be backed up, this needs to be part of your high availability strategy, everything. So you need to worry about that for sure. And obviously that you're provisioning a volume on a file system, so you need some space, and you need to leave some decent space for that. So in summary, when we talk about the durable percentage sys feature of cache, we are talking of separation of code and data is one of the primary advantages of containerization, and we are storing all the percentage sys data in an external file system, which is mounted as a volume. The external file system is identified in an environment variable. Multiple containers can use instance-specific data from the same external file system. And it again brings back to the same concept that it completely separates the build and the run phase. The run phase is now not configuring your cache parameters. That's again your part of your build phase. And obviously, when you're trying to upgrade cache and InterSystem address, then the instance-specific data is now available in the external file system location, and it's totally transparent. Any questions at this stage? I'd like to invite Ben. He's from InterSystems. They've been using Docker containers, so I'd like him to share some views.
Hello, I am from InterSystems, as he's mentioned. My name is Ben Cobb. I'm the lead site reliability engineer for the Ontario Cloud. And just give you a little bit of background, InterSystems is a software development company. We are a leading provider of receivables management software for companies from hospitals and insurance providers to banks and financial services companies, all the way to government offices. So we kind of provide a spectrum of services. But for the last few years, we have been investing in cloud software as a solution services and products. And so our new feature development has been focused in that area. And with that, we've been partnering with Luca and others here at InterSystems to work with Docker containers because of the advantages that we've seen with using Docker containers. And so they just asked me to share a little bit about how we've used them and what advantages we've seen with them. We do use AWS as our cloud provider. Our cloud-based offerings are powered by InterSystems Cache, and we are architected with a microservices architecture, just to give you some infrastructure specifics there. So one of the big advantages that we see in our development environments is that used to be we would have to set up each one and every one manually. But for our environment, we've got a pretty large federated system where we have anywhere from 5 to 10 cache instances to make up a single environment, depending on it. If you are working on mirroring or other HA type things at that juncture. So to set up an environment can be not incidental with setting up all the ECP stuff and all that. So we've found that by using containers, we can deploy a development environment that looks just like production, essentially, fully configured and ready to develop in a matter of minutes, as opposed to hours or even a couple of days. So that's particularly advantageous as we're bringing on new folks into the development environment, onto the project, or we use an agile approach, and so as priorities change and we need to shift quickly from one thing to another, or a high priority bug comes in, we might have a developer with 2 or 3 even development environments on their local machine. They spin one up, they're working on it, something else important comes up, they might just stop that one and pause it, bring up a new environment in a matter of minutes, make those code changes, commit them, shut it down, and destroy that environment and move on. So, managing your dev environment becomes a non-thing, because you can simply create one, at will, basically anytime you want. So if you corrupt one, you mess something up because you loaded a bunch of data in, took up a bunch of disk space, just destroy it and move on. It's no big deal. I'd like to also talk a little bit about our software development life cycle. We do commit all of our code into a code repository, and then we use Jenkins as our builds server. And so as soon as a developer commits some new change, the Jenkins build notices that, picks it up, and then goes ahead and creates the Docker image based off of that new code and the Docker file that's in the repository. Essentially, every one of our repositories has a Docker file in it, which describes what we want that Docker build to be. And so the Jenkins build uses that to create the Docker file, or to create the Docker image. And then as part of the process in a continuous integration type of environment, it simply deploys that as a container onto one of our build servers, and then runs our automated test suite against the new code, captures the results, tears it down, destroys that container, and then publishes the results. And so before we even get the QA department involved with every single commit that a developer pushes out, we've already containerized, captured that new feature, and run our tests against it. And then that image is then available for other developers to pick up and begin using as a basis for additional changes or testing, as well as for our QA department to take up and run their additional set of manual tests or regression tests or whatever. And then we're using those same images to transfer back and forth. So it just completely eliminates the conflict between the QA and the dev department about, well, what did you do different? Because it works fine for me. Did you, what's your environment? Let me go look over your shoulder at your PC. You don't have any of that, because everybody's running exactly the same thing, and you know exactly what they're running because they're running the same thing. I mean, even in a production environment, besides some of the advantages that have already been talked about, we see advantages from quickly being able to deploy things and containers to react in a microservices type of environment to scalability issues or HA type situations. We see a lot of load coming on. We can quickly and easily deploy another container that contains an additional web server to handle the additional load. And if it's a temporary thing, we have a big sales demo or something, we might spin up an extra one and we can tear it down very easily and quickly respond to things. Or in the case of a HA type situation, you have a production bug. Let's say you have a problem in prod. You can turn off that particular container and spin up another one in its place and let it let it take over essentially, and then you can leave that broken one there to go and debug at, at a later point. So anyway, some of the advantages that we've seen, some of the ways that we've used containers, we see that it's very flexible and easily deployed and quickly used technology, and something we've really embraced. So anyway, back to you. Mhm. Yeah, sure. We use Bitbucket as our source control, and so we do all of our development in branches. So every developer that's going to create a new feature, first thing, create a branch, do the development in a branch, do local testing on it with it, in their development environment, and then then commit it, into the branch. Then we do peer review pull requests on it, and then once those have passed, then the developer would merge that branch into default. And at that point is the trigger point for the build. Yeah. Other questions? We're not currently deploying the image to production because we've been waiting on some of these new features, like the Durable SYS feature that he's been talking about, that are upcoming. So we've kind of held off on deploying the image itself to production. So we have a different process that deploys to production today, but we're quickly going to be moving to this as soon as it's kind of generally available for our use. So we run in AWS. So in our production environments in AWS, we run Red Hat, and so we have a QA environment that's the final test. That's also a Red Hat AWS environment. But then our QA folks and our devs almost all use Linux Ubuntu. Or some of them run Windows and then run a virtual machine that's running Linux in it and then run inside of that, if they have other Windows development to do or something. Customer configuration, essentially. So most of that we store in one of the cache databases. And so then we would treat it just like this. It's stored on a volume that's external to the thing. And then we store all the config in the database. Yep. Any other questions?
Thank you very much.
You're welcome.
Cheers. I'll just finish up by saying that there are other sessions on Docker. We are already Tuesday, so Jeff is doing another session at 5 o'clock. No use of the Monday session. There's another session tomorrow at 1 o'clock. And obviously there is the ICM Experience Lab. If you want to see how we are using containers to provision instances in the cloud and deploy cache or InterSystems Iris in the cloud, you should go to those sessions as well. Thank you very much.